Right away, welcome back to Shabita e-learning platform, whereby we provide free education resources to our delightful community members. And in the last episode, we stopped on blood supply of the kidneys, and we had talked about the kidney removing waste and regulating ionic composition. Though this is not surprising that they are balanced supplied with blood vessels, we hinted on the kidney is receiving 20 to 25% of the resting cardiac output via the right and left renal arteries. They receive blood. Most of the blood first enters the kidneys before being transferred to other tissues, and this helps to filter blood, to prevent damage of the cells due to ionic imbalance like pH, osmotic pressure due to high levels of glucose in the blood. So the kidney helps to regulate the salt balance, to reduce the osmotic pressure. So in other words, an important way why blood has to first go to the kidneys before supplying other body tissues, to prevent damage, to prevent hemolysis, and to prevent very many life processes. Next on, we look at arterial supply to the kidneys. Within the kidney, the renal artery divides into several segmental arteries which supply different segments areas to the kidney. Each segmental artery gives off several branches, enter the parenchyma, and pass through the renal columns between the renal lobes of the kidney as the interlobar arteries. At the bases of the renal pyramids, the interlobar arteries arch between the renal medulla and cortex. Here they are known as the acute arteries because they arch over the bases of the renal pyramids. Branches of the acute arteries produce a series of cortical radiate or interlobar arteries. These arteries radiate towards and enter the renal cortex, where they give off branches called afferent arteries. Arterial system of the kidney automation. Each nephron receives one afferent arteriole which divides into a tangled ball-shaped capillary network called the glomerulus. The capillaries of the glomerulus then reunite to form an afferent arteriole which has a smaller diameter than the afferent arteriole. The afferent arteriole carries blood out of the glomerulus towards a second capillary plexus, the renal portal system. Capillaries of the glomerulus are unique among capillaries in the body because they are positioned between two arterioles rather than between an arteriole and a venue. Because the afferent arteriole is smaller in diameter, the afferent arteriole resistance to the outflow of blood from the glomerula is high. As a result, blood pressure in capillaries of the glomerulus is considerably higher than capillaries elsewhere in the body. This is important information because there would be a high osmotic pressure exerted in the glomerulus, resulting into outer filtration, where small molecules will be filtered out, leaving the large molecules like red blood cells and filtered out. So the afferent artery is divided into the pretubular capillaries, which surrounds tubular parts of the nephron in the renal cortex, extending from some afferent arterioles are long lobe-shaped capillaries called vasa recta that supply tubular portions to the nephron in the renal. So we look at the venous drainage of the kidney. The pretubular capillaries eventually reunite to form pretubular venules, and the cortical radiate interlobular veins, which also receive blood from the vasa recta. Then the blood drains through the acute vein to the interlobular veins running between the renal pyramids. Blood leaves the kidney through a single renal vein that exists at the renal ileum and carries venous blood to the inferior vena cava. Members, thank you very much for watching. We love you so much. In the next episode, we shall look at the nerve supply to the kidney. We have seen that most renal nerves originate in the celiac and aortico-renal ganglia as postganglionic neurons of the sympathetic divisions of the autonomic nervous system. They then pass through the renal plexus into the kidney along with the renal arterioles. Because renal nerves are part of the sympathetic divisions of the autonomic nervous system, most are vasomotor nerves that regulate the flow of blood through the kidney by causing the vasodilation or vasoconstriction of the renal arterioles. Thank you very much for watching. We really love you so much. Subscribe to Shability, turn on notification bells, like, share videos to friends, comment. We love you so much. It has been Dr. Derek at your service. Stay tuned for